This is lesson 3-5 and it's on symmetry. Please put your name, date, and period. The objectives for today, or the learning targets, are students will be able to describe the rotations and or reflections that carry a polygon onto itself. Students will be able to predict the effect of a given rigid motion on a figure. And students will be able to identify types of symmetry. Your vocabulary today is point symmetry, punto de simetría, reflectional symmetry, simetría reflexiva, and rotational symmetry, simetría rotacional. Example 1. Identify transformations for symmetry. All right. For example 1a, it's asking what transformations map the figure onto itself. So a transformation is like a reflection, a translation, a rotation. So we could reflect the image onto itself vertically. We could also reflect it onto itself horizontally. So reflections, and there are two. You could also rotate the figure 180 degrees. And it would come upon itself. For 1b, the same question, what transformations map the figure onto itself? And we have a line of symmetry. So there's only one line of symmetry that works. And if you were to rotate it 180 degrees, it would be upside down. So it really only has a rotation of 360 degrees for it to be symmetrical. And all figures have a 360 degree rotation before it becomes symmetric again. And then we have one line of reflection, so we can reflect it one way. Example 2. Identify lines of symmetry. How many lines of symmetry does a regular hexagon have? So we could go from vertex to vertex. That's one line of symmetry. We can also go this way. That's a second line of symmetry. And we can go this way. That is a third line of symmetry. And then we can also go through the center of each side. That would be fourth, fifth, and a sixth line of symmetry. And that is all of the lines of symmetry that a regular hexagon has. So it has 6 lines of symmetry. It also has rotational symmetry because you could rotate it a sixth of a turn, so that'd be 360 divided by 6, which is 60 degrees. So it has 60, and then you can just keep adding 60 degrees, 120, 180, 240, 300, and 360 degrees of rotational symmetry. Okay, so I'll highlight those different colors so you can see the difference. We have lines of symmetry, and then we also have rotational symmetry which is all of these 6 different ways that we can rotate it before it comes onto itself again. For 2a, how many lines of symmetry does this figure have? And how do you know you found them all? Well, I can't go diagonally because it won't fold on itself, and you could test that with a piece of rectangular paper. But we can go horizontally and fold it, and we can go vertically and fold it. So it has 2 lines of symmetry, and it has 180 degree and 360 degree rotational symmetry. Because if I turn it 180 degrees, it'll come onto itself, and another 180 degrees, and it'll come onto itself again. Or it will like line up with itself. For this trapezoid, there is only 1 line of symmetry. All right, and turn your page when you're ready. On example 2, I jumped ahead of myself and started talking about rotational symmetry, but that's actually supposed to be for example 3. For this figure, I could rotate it 90 degrees and it would line up on itself again. So I could go 90 degrees, I could go 180 degrees, 270 degrees. I'm just adding 90 each time until I get to 360 degrees. And the point of symmetry is here in the center because that's what we spin around. What are the rotational symmetries for this figure? All right, so it's going to spin around itself in the center right here. And 90 degrees would not work, but 180 degree rotation will. So that's the only one. And you could also say 360 degrees. Example 4. What types of symmetry does this figure have? All right, so we could reflect it one way. We could reflect the flower this way. And we could reflect it over this line of symmetry. So there are, oh, I see some more. You can reflect it over this line for 4th, and this line for a 5th. So it has 5 lines of symmetry. And it also has rotational symmetry. So if we divide 360 degrees by 5, because it had 5 lines of symmetry, let me think about this, it would go in 72 times. And then we just keep adding 72. So 72 plus 72 is 144. Plus 72 is 216. Plus 72 not sure I did that right. Let me check it. Nope. So 216 plus 72 is 288, and 288 plus 72 is perfect, 360 degrees. And that would be rotational symmetry. And I'll just abbreviate that. So we had 5 lines of symmetry, and we had 5 different angles of rotational symmetry. Rotational symmetry is used a lot in art and business, like marketing. So this example, number 5, is a way to use symmetry. A company CEO wants a new logo that looks the same for each rotation of 30 degrees and uses the 3 company colors. What are some possible logo designs? So I guess these colors would be gold and green and white. And if it's 30 degrees, then how many rotations would we have? So to figure that out, we would do 360 divided by 30. And that would equal 12. So all of these designs have 12 points. It would be a 12-sided or a 12-gon. So could you come up with another design that has a 12-gon? Maybe a flower. With 12 petals. It's not perfect, but if you had some software, you could make a design that had radial symmetry with 12 points. And those are your notes for 3-5 on symmetry.